Hello students, welcome back to my video. So in the last video we have completed the exercise 3.2, right? And I hope you have done all the homeworks. Now today we'll start the prime factorization. So what is the meaning of prime factorization? So prime factorization is the process by which a composite number is rewritten as the product of its prime factors. Okay, the meaning prime means what? You know, the meaning prime means the prime numbers. You have to factorize the composite numbers. Okay, composite number means numbers who has more than two factors. You have to factorize the composite numbers, and it can be rewritten as the product of the prime factors. So you have to write the product in the prime factors, in the prime numbers. Okay, like find out the product of 36, prime factors of 36. So 36 is a composite number, so you have to write the prime factors of the this 36. Prime factors means you have to write in multiplication form. In this way you have to break 36 equal to what? 2 into 18, and then you have got 2 as prime number, but 18 is not prime. Again you have to factorize this one. 18 can be written as 2 into 9, 2 9 is 18, then 2 is the prime number we have got. Now 9 is not prime, again we will write 9 equal to what? 3 into 3, 3 3 is 9, so we got 3 and 3 prime numbers. So in this way we have to factorize the numbers. So this is one of the method. Okay, so this method is called factor tree method. You have learned in your earlier classes. This is called a factor tree method to factorize any number. See, 36 can be written as 2 into 18. Okay, like this you have to make the arrows. So you have to make like a tree. So 2 into 18. So 2 is the prime number, so we'll leave this. Again 18 you have to factorize. 18 can be written as 2 into 9. 2 is the prime number we got. Again we have to factorize 9. So 3 3 is a 9. So what are the prime factors, or what are the prime numbers here? You have to write in multiplication form, product form. So what prime numbers you have got? 2 2 3 3. So you have to write in this way, in the product form. Product means multiplication form. 2 into 2 into 3 into 3. So 36 equal to this much. So this is the way of writing the prime factors in a factor tree method. Understood? So now write this 78 as prime factor. So again you have to make like this factor tree, and you can write. So this is the answer, 2 into 3 into 13. Okay, in this way you have to write. So in lower classes we have seen the factor tree method, but now in this class we will see another method that is called short division method. So prime factorization of a bigger number using the short division method. So we will factorize this 144. So express 144 using prime factorization. So this is the method of prime factorization. So in this way you have to do. Okay, you have to write 144. So 2, you have to, first of all you have to divide with 2. Always start with 2. So when you divide 144 divided by 2, it is coming 72. Again divide 72 by 2. So 72 by 2 divide 36 is coming. Then 36 right here. Again 36 divide by 2 is 18 now. Okay, 18. Then 18 divided by 2 is 9. 18 divided by 2 is 9. Now 9 is not divided by 2, so we'll divide by 3. 3 3 is 9. At last 3 1 is 3. So all prime numbers we got. So you have to write these all prime numbers in multiplication form. See, so prime factors of 144 are 2 into 2 into 2 into 3 into 3. These all prime numbers you have to write. So this is the answer of this question. In this way you have to write the prime factorization using this short division method. Understood? So in the next page it is given, express 945 using prime factorization. So you have to factorize 945. So 945 again you have to write like this. Then we'll see whether it is dividing by 2 or not. See, to divide by 2 we have to see the last digit, that means the ones place should be 02468. That is why we have learned the divisibility test in the previous video, right? it will help you to decide whether it is dividing by 2 or not. See, 5 is in the unit place, so it is not dividing by 2, right? Now we'll see, is it dividing by 3? So what is the divisibility rule of 3? You have to add all the digits. 9 plus 4 is what? 13. 13 plus 5 is 18. So 18 is dividing by 3. That's why this number is dividing by 3. So we'll divide this number by 3. So when you divide this number by 3, it is coming as 315. Again we'll divide this number by 3. It is coming as 105. Again we divide 105 by 3. It is coming as 35. Now 35 is not dividing by 3 because 3 plus 5 is 8. So 8 is not divided by 3. So which number will divide 35? So you know that 5 is in the unit place, ones place. That means it is divisible by 5. The divisibility test of 5 is what? In the ones place there should be 5 or 0. So here it is 5. That means 35 is divided by 5. So 5 7 is 35. Last 7 1 is 7. So at last write all the prime numbers 3 into 3 into 3, 5 into 7 in this way. Understood? So this is the way of writing the prime factorization. Okay? So do not make mistake here. So our next topic is HCF. Okay, highest common factor. Now we come to our main topic. So all these things, whatever we have read now, 3.1 exercise, 3.2 exercise, all were the preparation for this HCF. To find the factors, to know the divisibility test. Okay, all this will help to find the highest common factor, that is HCF. Our chapter name is what? HCF and LCM. So we got the first topic of our chapter, HCF. So highest common factor, you have to find out the common factor between two numbers or three numbers, and that factor should be the highest. That is why it is called highest common factor. Okay. So highest common factor of the two natural numbers is the largest common factor. See, the factor should be largest and should be common or divisor of the given natural number. In other words, HCF is the greatest number in the set of common factors of the given numbers. Understood? So given number, how many given numbers? Two numbers, three numbers. In between two or three numbers you have to find the HCF. So you have to find the common factor, and that common factor should be the greatest. That means the highest. That is called highest common factor. Suppose here you have to take out the HCF of 45 and 63. These two numbers. You have to find the HCF between 45 and 63. So how can you find it? One method is to factor method. Okay, common factor methods. First of all, you have to write the factors of 45 first of all. That's why we have learned the factors at the beginning. So the factors of 45 are 1, 3, 5, 9, 15 and 45. Then you have to write the factors of 63. The factors of 63 are 1, 3, 7, 9, 21 and 63. Now what we do, here we have to see what are the common factors here, common numbers here. So 1, 1 same, then 3, 3 same, then 5 is not here, 9 is here, 9, 9 same common, 15 not here, 45 not here, 21 not here, 63 not here. So 3 numbers are common. So there are 3 common factors. You have to write like this. Common factors of 45 and 63 are 1, 3 and 9. Now from here we have to see which is the greatest common, which is the highest common factor. So 9, you are seeing here, 9 is the greatest common factor here. So you have to write the highest common factor equal to 9. So HCF of 45 and 63 is 9. In this way you have to find the HCF of any two numbers. In this way, this is called the common factor method. Understood? In the next topic we will see HCF by the prime factorization method. So next method is prime factorization method that we have learnt now. Just now we have learned this method now. So you have to use the prime factorization method to find the HCF. So let's find out the HCF of 72 and 48. So how can you find it? First of all, you have to write the prime factorization of 72 and 48. See here. So here see, the prime factorization of 72 is written 2 into 36 72, 2 into 18 36, 2 9 18, 3 3 9, 3 1 3. Here 48, 2 into 24 48, 2 into 12 24, 2 6 12, 2 3 6, 3 1 3. So we have written all the prime factorization. Now you have to write all the prime numbers in multiplication form. So 72 equal to 2 into 2 into 3 into 3. Here written 2 into 2 into 3 into 3. and here 48 equal to, we have to write 2 into 2 into 2 into 2 into 3. So 2 into 2 into 2 into 3 we have written, right? Now here we have to make the pairing, we have to make the group of the same numbers, okay, which are the same numbers. You have to make the group like this, you have to circle it. So here you can see 2 2 here common, here also 2 2 common, here also 2 2 common. Now here 3 is there, 3 is not there, here 3 3 common. Okay, that means there are 4 pairs of the common factors. Okay, so you have to write what? You have to write these numbers in multiplication form. Now see, for this 2 you have to write 1 time 2. For this 2 you have to write again 1 time 2. For this 2 again 1 time 2, and for this 3 you have to write 1 time 3. That means for one group you have to write one number. Okay, like this you have to write and multiply every number. After multiplication the answer is coming 24. So HCF of 72 and 48 is 24. Like this you have to find out by prime factorization method. Understood or not? So this is the method of finding HCF by prime factorization. So prime factorization you have to do and take out the common like this, and you have to multiply all the common numbers. Understood? So for today you have to learn all these things. Okay, we have seen the prime factorization method, the common factor method to find the HCF. So in the next video I will show you another method of finding the HCF, that is long division method. Okay, till then study all these things. Okay, thank you.